So today we begin talking about how to do two-column proofs, which are something that you do a lot of in math classes from now on, especially if you end up taking a full year geometry course. You also do a lot of these next year in Algebra 3. So there's going to be a lot to take in. There's a very special method we have to use. It's not just, oh, I see that it's true. It's not, I believe it. It's you have to prove it. You have to give statements. This is what I'm trying to say, and here's my evidence for it. Much like being in a courtroom. So when you are doing two-column proofs, I need you to really pay attention, and I need you to write all of this stuff down. First thing you have to do when you're doing a two-column proof is you must include the picture of the geometric shape that we are talking about. They will usually give you a picture to start with, and then as you prove things about it, you add labels. These two angles are congruent. These two sides are congruent, whatever is going on. You do a list of statements on the left, and we put a number on each one of those, 1, 2, 3, 4, however many we need. And then on the right-hand side, we do reasons, and they have to be numbered to match the things on the left-hand side. You do have to have numbers on the left and the right to help somebody make sense of what goes with what. These are going to be the proof, the evidence that you're presenting in court, why the thing that you're proving is actually true. So I'm going to pause and give you a moment to get this part copied. Now on this slide, you do not need to copy it down because on the next slide I'll give you a shorter version of it to write down. This one's going to have all the words in there. We want to do a lot of things where we have, here's one triangle and here's another triangle, and we want to prove that they are congruent. And does anybody remember what it means if two triangles are congruent? What does the word congruent mean? What do you mean by equal? Because I could have two triangles that have the same area, that their areas are equal, but they're very different shapes. Like the angles are congruent and the angles measure the same. That's two ways of saying the same thing. That is true. That's part of what it means to be congruent. All of the angles match up. They have exactly, this angle has the same measure as the matching angle in the other one. What else though? Would I say those two angles are congruent, even if those angles match up? Cannon, what do you think?
No.
Why not? What's different about them?
The size.
Okay, the angles have to all match up, and all of the matching sides have to be congruent. So all 6 of those things are true if they're congruent. We're going to start doing proofs where we only have to know 3 or 4 things are congruent to be able to say. So it kind of lets us not have to go through all 6. So the first one is going to be if we have 2 triangles and all 3 sides are the same. So if those 2 sides have the same measure, so I'll do 1 tick mark on each of those to say they measure up. And again, we'll have a shortcut version of this on the next slide. These 2 match up and have the same measure, and these 2 match up and have the same length. That would be enough to say they are congruent, and so therefore all of the angles also match up. We would abbreviate that in our proof with SSS for side, 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 so we don't have to do quite as much proving. These are going to be major premises that I let you just accept that they are true. That these have the same shape and size to be congruent. The next one that we could do would be what we call side angle side. And in that case, we have 2 sets of the sides, not 3 like we had in the first one, but maybe we know that this side is congruent to that side. And maybe we know these 2 sides are congruent, but we don't know yet about the other side. We do, however, know, and this part is important, The angle has to be in between them. That's why the A is written between the two S's. So this angle over here is the one that if I just had those two sides that I marked, that's the angle they'd actually make. That's the one that has to be congruent. If I have that, by side angle side, I can say that the two triangles are completely congruent, and the other set of sides matches up, and the other two angles will also match up and be congruent. The next one that we have, and not all books do it quite this way, but angle, angle, angle side. If I know that all three sets of angles match up, so those two are congruent, these two are congruent, and I also know that the third set is congruent. Now remember, we said that wasn't quite enough. Those pictures that I drew at the very beginning up at the top had angles that all matched up. So we also need one set of sides, and it does not matter which set you like, so I'll pick that set right there. Then we would say we know three sets of angles all match up, and we know one set of sides matches up, so angle, 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 side means that they are congruent triangles. And then the last one of these that we use is hypotenuse leg. What kind of triangles have a hypotenuse? James? Only a right triangle. So the fact that we say hypotenuse means we also know that it's a right triangle. So we really know three things about it. We know that it's a right triangle, so we know that. We know the hypotenuses have the same length, and where's the hypotenuse? Who can tell me where the hypotenuse is? Abby, you want to unmute and tell me where the hypotenuse is on a right triangle?
Along the diagonal side?
I think you're on the right track, but those triangles could be rotated into any position. Is there a way I know it?
Opposite the right angle.
Okay, it has to be opposite the right angle. So the hypotenuse is always opposite the right angle. We must know that side. Then, if we also know one of the legs, then we can say that it is congruent by HL for hypotenuse leg. If I knew for two triangles both of the legs and that they were right, do I know the hypotenuse in that picture? No, but the angle that I know is between two of the sides that I know, so that one would be SAS. So SAS might work on a right triangle, but if it's the hypotenuse and the legs that the angle is not between them, it does work. If it is important for you guys to make note, SSA does not make them triangles. If we know two sides and one angle, but the angle is not between them, that's not enough to be congruent. And AAA is not enough. I'm not sure if it's So here is one with two triangles, and can you see that they don't look like they're congruent? If we look at this angle C down here at the bottom, or R on the other one, it's acute on the one on the left and obtuse on the one on the right, so they're not congruent. But they're saying that this side from A to B is the same as this side from P to Q, and the side from B to C is just as long as the side from Q to R, and they've got the A and the P labeled as congruent. So they've got two sides and one angle, but that angle is not in between the congruent sides. Does that make sense to everybody? And I already showed you a picture at the very beginning of why AAA won't work. So let's get the shorthand form for you to copy down now. And I will add in some notation on this. So I'm not real worried about your formula numbers, but from the lesson on proofs, SSS means that the triangles are congruent. And so you want to do a little picture where you just label those. That all three sets of sides match up. The next one is going to be SAS for congruent triangles. Copy down, please. And that's going to mean pick any two sides that you want. I don't really care which ones you want to label on your picture. So I'll label those two sets of sides. And the A says the angle that we know that's congruent must be the one between those two sides. So it must be that angle. Are you getting it all copied? Angle, angle, angle side is what we use. It means we know all three sets of angles match up. So 1, 2, 3. And it means we know one set of sides matches up. So pick whichever one you like and label that those match up. I didn't get that one. Make sure I don't skip anything on any of these labels as I get them up here. Proofread for me. And then our fourth one, these are going to be our 4 ways of doing these. Our fourth one is going to be HL. And it only works for right triangles. So that means we know the hypotenuse, we know the leg, we know it's right. So we must have a right angle in that triangle. We must know that this hypotenuse is congruent to the other hypotenuse. And that doesn't matter which one of the other sides you pick. They're both called legs, but one of the other sets of sides matches up. Those are your 4 ways that you may prove that triangles are congruent. Anybody need me to wait, or are we good to go on? I've gotten that copied down. All right, let's continue, and let's try thinking about a couple of other things that we will use, and then we'll jump into doing our first proofs. Reflexive property simply means something matches itself. So in this triangle, I can say DB right here in the triangle on the left is just as long as DB in the triangle on the right, because DB is the same as itself. I could also write that one, DB is congruent to BD, because it's still the same line segment. Order is going to matter. We'll see in a little bit in terms of how we write things in our statements, what we want to match up. I can also say in here that angle A in the triangle on the left, ABD, is the same as angle A in triangle ACD, although those triangles aren't particularly congruent, but A is the same as itself. However, in this one, I cannot say D is congruent to D, because I have 3 different angles up there at angle D. I have this one that I'll mark in blue, angle ADB. I have this one that I will mark in red, angle BDC. Those 2 look congruent. They may or may not be. I don't really know. And I also have angle ADC, the really big one that goes all the way across there. So if I just say angle D, I don't know which one I'm talking about. We are going to use this a lot. AA implies AAA is how we'll read that. You write it with an arrow, not an equal sign. That means because of triangle sum, if I know these 2 angles, one in each triangle match up, and these 2 angles, one in each triangle match up, and they both got to have triangle sum equaling 180, that means the remaining angles have to add up and be congruent. So if we have or prove that two sets match up, that automatically means the third set matches up, but we have to put that into our proof. It is not true that SS implies SSS, so don't try to pull that one in your proof. That picture that I just showed you when I went to that other website real quickly, two sides matched up, that does not mean the third side matches up. I think we're ready to kind of start trying to use some of this now. So you will have some homework problems that look like this. Which congruency postulate, so SSS, AAAS, SAS, or HL, which one can you use to say the triangles are congruent if you have pictures that are labeled like this? These congruency statements here, the order matters. That is saying because A is in the first spot that A and D are going to be congruent angles. It is saying because B and E are in the middle, B and E will be congruent angles. C and F are last, so C and F have to end up being congruent. And it also says, first two letters AB, side AB has to be congruent to side DE. It also says that when we're done, BC has to match up with EF, and in addition, that let's see what's left. DF has to match side AC. They're not going to give us all six of those things, but all six of those things have to end up being true. So we look at which ones they give us. They have labeled the angle up here at B is congruent to the one down here at E, so that's good. The B and the E are in the middle. They have also given us that A over here is congruent to D over here, and that's good. A and D were both in the first position. And they gave us a side, DE over there and AB here, and sure enough, AB the first two letters, DE the last two letters. So, what do we know? Do we know all three sides? Have we labeled all three sides on those triangles? Sarah, can you tell me which one we're going to use? What pattern does that match?
Maybe BC and FE.
Now, I'm out of SAS, SSS, or AAAS, or HL.
AAAS.
Do I have all three angles?
Yes.
Do I have them all labeled already?
No.
What's
Oh,
all?
so SAS.
So SAS. I could go through some other steps and say AAAS, but I'd have to have a couple other lines in my proof before I could do that. Okay, let's take a look at the next one. For this one, we're looking at WXZ, so the triangle on the left half, and YXZ, so the triangle on the right half. They have labeled the longer diagonal sides on those, and they've labeled angles up at the top, but that's only two things. I thought I had to have at least three things to say triangles are congruent. Is there something else I know by looking at the picture, Clayton? I don't know that. They might be really, really close. That could be just barely leaning. It'll actually end up that they are, but that's not labeled that it's a right angle or that it's a hypotenuse. But there's something else I can use. James?
I was going to ask for the first one. How could it be deciding what side of the one?
Oh, you're exactly right. It isn't. And Kara was on the right track. It's Monday morning and my brain's not working at full force. My apologies on that, and thanks for the correction. We'll go back to number one. What I know is angle, side, angle, and that's not enough to say they're congruent, is it? So I would have to say on that one, my third set of angles by AA implies AAA, and then, yes, you were exactly right at first, Kara, angle, 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 side. Forgive me, my brain's functioning like it's a Monday morning too. I've got to have you guys keeping me on track. Okay, let's go to B again. We know one side and one angle. I got that right so far, right? Can I figure something out about another side or another angle, Molly?
The middle angle can be separated into two.
Well, they already have that separated into two, and they've said those two little pieces are congruent. So let's look at this another way. I'm trying to say this triangle and this one are congruent. I've said the angles at the top of the blue and the purple match. I've said the ones on the sides on the outside match. Connor, what else matches up?
The side XZ is congruent to side XZ.
They share that side, and with that reflexive property, that side has to be the same as itself. And what I like to do is to put a little circle on a side when I'm saying that it's reflexive property, so I don't have, where's the other one? Where's the tick mark that I'm missing? That lets me know, oh, I'm just looking at this one spot. So now I have those sides on the outside. I have the side through the middle, and I have the angle up at the top. Does that match one of our patterns, Riley? Have I marked all three sets of sides? So it's not SSS. Have I marked two sides?
Yeah.
And I've marked an angle. Is the angle in between them or not?
Yeah.
So the angle's in between, so that one's going to be SAS. Couple more of these and we'll go on to a full-blown proof. Okay, this one's probably going to be kind of easy for you after that last one. So they want to show PQR, that's this one over here on the left, and they want that to be congruent to PSR, so that's this one on the right. They have marked these sides and these sides. Viola, can you see something else in that picture that we can say is congruent? Because we know we've got to have at least three things that we know about on a triangle. How would we know that? They haven't marked it. We can say they tell us and it's marked. We can say angle, angle implies angle, angle, angle if they've already marked two sets of angles. We can say an angle or a side is the same as that same angle or side. So is there something in here where we know the same for the left and the right? Okay, they share that side in the middle, PR. So now what all have I marked, Ryan? So I've marked all three sides, so they are congruent by side, side, side. If it absolutely can't wait, you're going to miss important stuff if you leave. So ABC congruent to ADC, so the top and the bottom. On this one, they have marked this little square right here. What does that mean? Everybody. We've got a right triangle. Now remember, that may mean hypotenuse leg or it may mean side angle side, like I pointed out when we did our list of the properties. So let's see what else we know. They have marked AB and AD. Are those hypotenuses or legs, everybody? So we know, so far I know right, and I know the legs match up. Which side for the top triangle is the hypotenuse going to be? Sophia, for that top triangle, which side is the hypotenuse? So AC, because remember the hypotenuse has to be across from it. What side is the hypotenuse for the bottom one, Sarah? Do I have any way of knowing that AC is the same as AC? It's the same as itself, so that's our reflexive property. So then, yes, we do know the hypotenuses. We said we know the legs, we know that it's a right triangle, so this one would be by HL. So is that kind of starting to make sense? Okay, another thing going way, way, way back, remember vertical angles? You may have those in proofs and they're congruent, and we would abbreviate that with VA. but we will always have to use 3 letters. So A, B, C. So I can't just say angle B is congruent to angle B, because that one also has a vertex at B. And am I talking about a red one and the green one, or the 2 green ones? I don't know if I just say angle B. So I would have to say angle ABC is congruent to angle DBE, with the B's in the middle to show that's where it bends. Start at A, go to B, go to C. I have that angle, and similarly for the right side. Okay, so copy down. We're going to do our first complete 2-column proof now. So copy down your picture with all of the letters, and make it try to look pretty much the scale of what you see up here. When you're doing these in your problem set boxes, you have to do it kind of small, because you still have to do a whole 2-column proof in that box. You are going to start out by labeling on the picture anything they tell you is given. Sometimes they will go ahead and just mark it in the picture as a way of telling you what's given. Sometimes they'll do it with words and symbols like this. So angle A and angle B, when you do a little curve and 1 matching tick mark. They also tell us CD and CE. So that's from C out here to D. So we're going to do 2 tick mark. I guess it doesn't matter. And C to E, I could have just done 1 tick mark since it was my first side, or the 2. So we know those are congruent. Okay, we don't need to copy this down yet, but we need to prove that the 2 triangles are congruent. So the way that we do a proof, we do a T-table, and you actually write statements and reasons. And you need a list of numbers on both columns, not just on the first column. So number 1 and number 1. We must start out with everything that is given. So angle A is congruent to angle B, and the reason is given. Number 2, side CD is congruent to side CE, and that is also given. Thumbs up, thumbs down. Okay, exactly like this is going to need to be our very last line of the proof. That's what we're aiming for. So far, I know 1 set of angles and 1 set of sides. That's not enough to say the triangles are congruent. So what else can I say is congruent in this triangle, Connor? Are there any sides or angles that they share that it's exactly the same?
Angle D is congruent to angle B.
And it's going to end up that that's true, but I have no evidence yet to say that. So maybe it's reflexive property like we've done, maybe it's vertical angles like I just mentioned. Can you see anything else in there that we've got a reason to know that they have to match up?
Angle C is congruent to angle C.
So the angles at C are congruent. Can I use just the letter C when they're vertical? I've got to actually write out some letters for those. So for this one, and this is going to be important, so really pay attention here. First angle, I can write the letters down in whatever order I want, as long as C's in the middle to show that that's the vertex. So symbol for angle, ACD, is the one that I just wrote down. And I'm going to use vertical angles to say that these are congruent. Now for my other one, I can either say BCE or ECB for that angle, except in the proof there's only one way I can do it. I have to make sure that they match up over here. So I did ACD over here. So I look at my congruency statement. I've got to keep my letters in the matching order. Since I did ACD just like here, I've got to do BCE just like there. And not ECB. So far, so good? Okay, so now I'm going to draw that on my picture. And this time I'll use 2 tick marks, since I've already used 1. Okay, now I know 2 sets of angles and a set of sides. Is that enough to say congruent triangles? James, what else do I need?
You can say that 2 angles means that the other angle is the same.
Now we get to the D and E, but we had to get this evidence presented to the jury first. Now we can indeed say, and we only need 1 letter for those, since there's only 1 angle at D and 1 at E, and that's going to be AA implies AAA, and we use the arrow. Now we mark that on our picture, and this time I'll have to do 3 tick marks, because I've already used 1 and 2. Now I have all 3 sets of angles and a set of sides. Sarah, is that enough for them to be congruent? By which one of our postulates? AAAS. We know all 3 sets of angles. So angle, 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 side. And we could say, since this is our conclusion, therefore, now I'm going to make it match exactly what I had up there. Triangle ACD is congruent to triangle BCE. And that was your first 2-column proof there. Anybody with questions on that?